Well, welcome everyone. It's a pleasure to kick off today's joint seminar. I think it's a much better day to be inside than outside. It's a real pleasure today to introduce somebody who has such a history with the Thayer School of Engineering and kind of almost, I would say, personally manifests the theme of this seminar series, which is Technology, Science, and Society, and what you can do with a Thayer degree and have a major impact in science and society. Professor Narku Quaynor is a scientist and engineer who's played an important role in the introduction and development of the Internet throughout Africa. He graduated from Dartmouth College in 1972 and finished with a Bachelor of Engineering from the Thayer School here in 1973. He then studied computer science, obtaining a master's and a PhD from the State University of New York at Stony Brook, finishing in 1977. He is one of the founding members of the Computer Science Department at the University of Cape Coast in Ghana, where he continues to be a professor and teaches classes in electrical engineering and computer science. He's a member of the Council of the University of Ghana. Upon his return to Ghana from the United States, he established one of Africa's first internet connections and was involved in setting up the key organizations, including the African Network Operators Group. He introduced value-added networks in the region throughout the introduction of the SWIFT Internet Commerce Networks and was founding chairman of AFRA-NIC, the African Numbers Registry. Dr. Quaynor is the chairman of the Ghanaian company Network Computer Systems, a member of the United Nations Secretary General Advisory Group on ICT, a member of the ITU Telecom Board, chair of the OAU Internet Task Force, president of the International Society of Ghana, Internet Society of Ghana, and was a member of the World Bank InfoDev Technology Panel. In 2000, he became director for the African region of ICANN, the Internet Corporation for Assigned Names and Numbers, which is the nonprofit organization responsible for coordinating the maintenance and procedures of databases related to the names used in the Internet, ensuring the network's stable and secure operation. In 2007, he was awarded the Jonathan B. Postal Service Award from the International Internet Engineering Task Force. In 2013, he was inducted into the Internet Hall of Fame by the Internet Society, and he serves as a commissioner for the Global Commission on Internet Governance. So it is a real pleasure to have you here. Thank you so much.
Thank you very much for the kind words. Thanks for the very good welcome. I like to share what I think it takes to develop technologies in Africa. By taking a look at how the internet got into Africa, and then perhaps ask more general questions regarding new technologies. How might we fare? So I want to take a look at the internet and blockchain, but first look at the experience of how we acquired it, the internet, and I saw there 4 different phases. And then I want to advise on what we might do with the blockchain type of technology and acquire it much faster. What I have in mind is that this is roughly how we adopted it. It can be broken into 4 parts. And you'll notice that in the foundation, we were really preparing the preconditions, and I'll give some more detail. But in the beginning, we were trying to put the first connections into countries. Remember, at this time, there was nothing. No country had connectivity in the early 90s in Africa. And then after that, we began to self-organize ourselves and begin to establish structures that will help the development of the internet. And lastly is where we saw the growth and the true formal institutions emerging. Now, in the foundation, you see familiar things. That's where we started building computer science departments. Most of the countries were doing that around that time. We had a monopoly telecom, meaning one company acting as provider, regulator, policymaker throughout. But we also experimented with enterprise-wide computing using IBM systems or DECnets and so on. And at the same time, the email scene was starting using FidoNets and UUCP and things of that sort. But the important thing is that PCs were coming in around that time. In fact, PCs showed up around 88, 89, and that really was an important precondition. If we didn't have PCs, we could not really do the internet. And we noticed around that time, many different companies, SMEs, began providing training on PCs and so on, therefore opening the door for the internet to come. The next phase was moving from proprietary networks like DECnet in my case, or SMA in the IBM case, to a more open standard like TCP/IP. And the main issue was connectivity. We had nothing, no cables anywhere apart from what was owned by the telco. So we had to do wireless tricks. And if the customer is not far from you, you string a cable. So we're really improvising. And there were telecom tensions because the single operator could not rationalize why you want to replace him. Let me put it that way. And at the same time, we saw the emergence. Because we had an email, then you can have domain names. So if you are in a country like Senegal with SN, then you may want to have an email address at something.company.sn. Okay, those things were beginning to emerge. And around that time, early 90s, web became available. This is what I'm really describing in the sense that in 91, the only country that had any connectivity was Tunisia. And if you notice, yellow is no connectivity, green we had only email. This was how barren it was around that time. Then came the self-organizing period. In this case, we were trying to go to secondary cities. So we've got things in Accra. We wanted to go to Kumasi or the secondary cities. And then we were also pushing for telecom policy reforms. In this case, we wanted to separate the posts from telecom. We wanted to establish an independent regulator, so that there can be a competitive field of operators. In the beginning, everything was one operator, did regulation, policy, provision, etc. So we had to separate them. And there was also global efforts to coordinate things around the internet. In fact, ICANN started in 98. So you can see this is about the first time we began feeling like the internet had to be managed or governed, depending on how you see it. And African participation in the global space was also starting. So we had a major meeting in Cotonou that we call the Cotonou Convention. And that is when I defined the various technical institutions that we needed to build in Africa if we were to sustain the internet. And what we used to do was go to meetings, come back, train our colleagues, share, and so on, because there were so few of us. And so the only way we could do it was when you go somewhere, collect as much knowledge as you can, you come back, try to share it as much as you can, and so on. But mobile arrived, making another big difference, just as the PC did. And you notice that by, in this case, 97, we've almost finished covering, except for difficult countries like Somalia, which turned out to be the last one to get connected in 2000. Then the last quadrant is actually where we began building the institutions that I had been pushing throughout, like the Numbers Registry, like the CCTLDs, and so on. We had to now put them in place because prior to this time, north of the equator was handled by Europe, below the equator was handled by North America, and then in the Indian Ocean, they went to APNIC. So we were torn apart, meaning that we could not really route traffic on the whole continent because you have to change addresses, okay, and it doesn't work. You want to have one address domain so I can route from Cape to Cairo and so on. So we had to do things of that sort. Of course, we inherited new issues, cybersecurity problems, cross-border connectivity. Okay, some of our countries are landlocked, and so we had to address those issues as well as accept the method of multi-stakeholder bottom-up policy development process, which was something new to us. We were used to you decide from the top and you push it down. Now we had to learn a new style, which was multidisciplinary, multi-stakeholder, bottom-up approach to development. In essence, at the Cotonou Convention, I defined a group of technical institutions we needed to put in place. And the first one to get off the gate was this network operator group, and that became the environment in which we incubated the numbers registry, the CCTLDs, and then the rest followed: registrars, research networks, emergency response teams, and the latest one to join is .Africa, which is a regional TLD, okay? And so if you have a .GH name, it's also good to have a .Africa name so that you can have a local address, a regional address, and maybe a global address. And the one that I'm pushing now as another not-for-profit is this fellow, whose job is to improve the TLDs and the registrars, their engagement in terms of how you acquire names, how you pay for names, how you transfer names, and so on. Now, with respect to technology shifts, it's worth looking at it from at least policy, infrastructure, workforce, and governance. And you can see as we went across, things were beginning to relax more. So you can see policy move from one telco doing everything through reforms, having an independent regulator, and then creating a competitive environment. And in infrastructure, you had only one national operator. We separated the post from it, okay? And then you began to have private sector-led development. And then, of course, at maturity, we have a mixture of government running its own network and then private sector running the rest of the network. Workforce, in the beginning, everything was in the telco. They were doing mostly switches and that kind of thing. Then we began seeing computer scientists entering the workforce because we had previously, in the previous, started producing them. So some of them were graduating, and then industry was beginning to start. I was running a system integration company around that time. And then eventually we had what we might describe as proliferation, but without critical mass. Now we're still fighting to build critical mass. Though we have a lot of people, we don't have much critical mass in one place. And in terms of governance, it was really government doing it. And then they started shifting to more corporate approach. And then they were forced after the reforms to have industry dialogues. And so you can see things are moving, and gradually we end up with multi-stakeholder approaches. So observe the following technology shifts in our area. We had the UI change to PCs, followed, of course, by mobile. And we're beginning to see devices also coming in at this point. And we had already adopted the TCP IP over the switching of the telcos. And also web had entered the game in about 92, 93. And so people were beginning to develop applications. CCTLDs were in existence. So you can see that we're beginning to add more things to it. Now, the basis now had been a setup for more secure use of the internet. So if you see HTTPS, all these things were around that time. Public key infrastructure, online businesses were beginning to emerge, and you've seen the things we've done with mobile money and so on. Still on the technology shifts, we had to shift from, to a private sector-led kind of environment. Policy and standards, became in the hands of multi-stakeholder communities. And a good example of this bottom-up thing was in the transition from when we were still under U.S. government to becoming totally independent in ICANN, what we call the IANA transition. was a good example of what a multi-stakeholder bottom-up approach can do. The issues which have emerged at this point were potential fragmentation and the issues of net neutrality as you see them, and potential weaponization. There's still cross-border issues, privacy issues, and rights. And of course, now we've inherited governance of the internet itself, okay, and then governance of the behavior on the internet. The one off is what we normally call technical coordination and administration, okay, because things are very distributed, and that's what we do. Now, let me switch the subject. So this is what happened with the internet space. So the question is, if there's a new technology coming, how are we going to go about, this took 20 years. I don't want this next one to take 20 years again, because then the divide is even worse than it was before. But why is there so much excitement about blockchain from my perspective? If you have an ordered permanent records with timestamps, I am sure there are many applications where you need to have some things permanent. Okay. Logs, as example. And the records may be anything. They may be transactions as we know them with Bitcoin and cryptocurrencies, but they could also be just data. In that case, they tend to be hashes, or they could be programs, as you have in the case of Ethereum. But blockchain, once you put something there, you cannot remove it. So if you put a program there and there are bugs in it, then the bugs will live there. Okay, you have to start afresh. But to do this, several computer science techniques are employed. They use the networks to share the blocks, discover who has blocks, and then share it among yourselves. So if I open a new machine today and I want to get existing blockchain, I go to a seed, then I ask the seeds, then they tell me where I can find others. In the process, I can get the blocks one by one until I have the full set. So they use the networks to broadcast, or you can discover and ask for what blocks you have. They use the cryptography to keep the chain, in some sense, tamper evident. In other words, they put hash of the previous, a digest of the previous set of transactions inside the next one. So if you tamper with the past transactions, it will affect the integrity of the whole chain, and it's tamper evident. We also employ consensus, algorithms, meaning how do you know whether this block is good enough for me to add to? Okay, so there are rules, and the rules are also connected to rewards. So, for example, in the case of yesterday's presentation, we have proof of work. That means you have to do some work based on the data and get a hash. There's proof of stake, where you look at who are the big persons with big purses and have them decide. We are proposing more proof of presence. If you can demonstrate that you have a presence on the web with the right pieces of information, the DNS resource records, then you get rewarded. And of course, the smart contracts with respect to Ethereum, where the programs are actually living on the block, is an example. But you can play. What if we generalize? Normally, it's address, value, address. Source address, destination address. Value is the money I'm moving. But what if the value is generalized to not just a coin, but some other asset? Okay? Then it means that you can transfer assets, you can transfer rights. But since we are talking about key pairs, cryptocurrency, cryptography, key pairs, private key, public key, then it means that the one who is transferring must demonstrate that he is the owner. Okay? So we do that with the coin, but we have to do the same with assets. And you can do this through a private blockchain, but I prefer the public blockchains, because that is when you can reach everywhere, and it becomes more like a value on the internet. Now, observe that if you have not earned the money, you cannot spend it. So if your address has not appeared as an output in a previous transaction, not immediately before transaction, as a previous transaction, then you don't have the ability to spend it. And they have a technique which sorts it out. So what if what you put on a blockchain is just data? Then it means it may be a digest of some other information, and then you are putting your integrity check there. Because Bitcoin allows you to have a payload of about 80 bytes. So I can have a complex data somewhere, but I can hash it and put the 80 bytes on the block. So I can verify whether my data is the same as what it was before. So in that case, you do the interpretation of the data by programs on the web. Okay, and if the interpretation becomes unwieldy, then you design state machines to deal with that data. Okay, so that's what we normally do. Now, if it contains code, then you've gone into the world of Ethereum, and that's smart contracts, and they talk in terms of autonomous agents, and then these agents, in essence, can be called because the contract has functions, and you can call the functions. But this is the first time that we have applications that know about money or know about assets, and so it's a major breakthrough. In the case of Ethereum, state changes are affected by transactions. So a transaction to send money will modify the state of all the variables that are referenced in the before state to get a new state. So it's state transitions that move you from state to state. Once again, I just 2 days or 3 days before coming, I said Bitcoin is an example, the leading example using blockchain. Let's take a look. And you notice the same pattern you saw here. Yeah. This is Africa. Apart from Ghana, Nigeria, and South Africa, it's empty. Okay? You can see that similarity. And North America is beautiful. See, Europe is fine. Australia is not bad. Southeast Asia is okay. Almost the same, as before. So are we seeing deja vu? Are we coming back to the same thing? And what do we have to do to repair it? Of course, blockchain comes with its own nuances. Records are immutable. They also handle identity management. Now, this is the risk. This is the risk because your identity is in a key pair. So if somebody takes your private key, then I think you've lost your identity. And we need to be careful with that. And we like to have the permissionless environment with respect to the ledger itself. And the copies of ledgers are scattered all over tons, tens of thousands of machines. And we like to preserve the peer-to-peer transaction nature so that if we can trust ourselves, we don't need an intermediary to help us do that. People think that it's anonymous. It's not anonymous. It's pseudo-anonymous. Now, you can look at it as from the point of view of network layers. We are very familiar with the lower layers. We know the physical layer. The logical layer is the TCP/IP. The web may be a social layer. That's where most of your, social media systems live. But we think this blockchain thing is going to bring some more trust, and it could bring an economic kind of layer as well. From the point of view of data structure, we can think of it as just the normal way, except that when you put something on a block, you get a transaction ID back. So if you keep the transaction ID, you can always read the data. Much the same way as you do with your databases, okay, and much the same way as you do with files. So notice that it has different perspectives, and all of them are needed. Now we see a software opportunity here because once we can write software that understands money, can understand assets, then we can do more complicated things. And we also have to now think of how we use the immutable data that we have. What application, in every application, you have to ask yourself, what are the things that you want to preserve permanently? If none exist, don't touch it. But if you can discover things in your application that need to be preserved, okay, ad infinitum, then you have a blockchain solution. You can view it as an asset, okay? Meaning, remember I said you can change the value to anything, and if that is the case, then we have to have some things recognized in the sense that the assets must be recognized in law, and tax is very important. And we wonder what institutions must we put in place in order to govern this thing. It can't go forever by itself. The internet went for a while, then we had to create ICANN to help govern it. So the same must happen in this environment. And we want to make sure that Africa doesn't fall behind or take as long as it did with respect to the internet. You can also view it as a registry where you are deliberately putting things in a registry. And in that case, then you want the openness and you want to contribute to the machines that decide confirmations of the things that go into a block. So if you don't have miners in Ghana, it will be very difficult for banks to trust the blockchain, as an example. And I've heard a bank say that, oh, is that thing they use in China? Okay, because he's heard that most of the miners are in China. Okay, so he seems to think, therefore, that it is not something in Ghana. So that means that we have to have more mining. And at University of Cape Coast, we joined a group called bsafe.network out of MIT, Cambridge, and so on, to kind of try to help develop better software for the blockchain. And I think we need to be developing future industries in this area. So once again, there must be some technology shifts. So if I use the same 4 axes, I expect that if you view it as an asset, then you need to recognize that asset. And if it's a coin, then you must recognize the digital currency. And at the same time, we need to add more nodes. Nodes are the guys who are the full blockchain. And we also need to have those who mine, those who collect the transactions, so to speak, and confirm them and connect it to the chain. We need to have more of those. Otherwise, no one will believe us. Now, workforce is new. So we have to rush to create people who know and can write programs there. And the governance, we will still inherit the internet's headaches of governance of the infrastructures and governance of behavior on. Meaning the governance of the behavior on is more a social regulatory kind of issue. It's about stopping criminals, okay, or bad actors. So, for example, that is where the issue of the exchange conversion of cryptocurrencies to fiat come. And those things must be regulated, okay, because you are converting from something to some sovereign currency, and that's an important thing. But if you think of it as merely a registry and you can put anything there, then I honestly think everything should be open, okay? You need, because I'm not really converting into any regulated currency. So everything ought to be free. What stays there is that in the infrastructure we don't have, as you saw in the diagram, we don't have any nodes there. So we have to put more nodes, okay? We don't have many miners, so I mine. I mean, it may not be profitable at the current price and the cost of 42 cents per kilowatt hour, but if I don't mine, I don't believe the banks will accept. I won't achieve the change I'm looking for. Okay, so I have to mine. So I have to find ways by which I can create my own power, so I don't depend on the 42 cents per kilowatt hour so much. Well, what I can say in conclusion is that from the internet experience, it took 20 years, okay, to really acquire the technology to a point where we could carry it on ourselves. I think I want us to adopt the blockchain a lot faster and benefit from the opportunities it brings. But I see central banks concerned about it, but they always talk from both sides of the mouth. They say, we don't like cryptocurrencies, but we like blockchain. Okay, but the first application of blockchain is cryptocurrency. So who is going to come and invest only in blockchain in your country? It wouldn't happen. I mean, when he brings up his blockchain, he will test it with something. And I bet you it will be a cryptocurrency. I mean, because that's the most natural way to test. And the last point here is that we should be aware that technologies get deprecated. We don't have fax machines anymore. So if we fall behind and keep using fax machine, then today we'll be completely isolated. So if everybody is moving in the direction of cryptocurrency, blockchains, then I think Africa should also move. And if we don't, the current methods we use may become deprecated. And when that happens, we'll become isolated. And I think we need to try to build businesses and communities around these topics, and that is what I'm trying to do. So thank you very much for your attention.